colleagues, it's time to start. My name is Alexander Lavrik. I'm a researcher of Scientific Center Arctic of St. Petersburg Mining University. And the topic of our today lecture is renewable energy. Renewable energy in general and of course in conditions of oil and gas industry. I'm sorry for my bad English, but I will try to speak better. And also I hope that you will have no questions after the lecture. Of course it's a joke, but I hope on your understanding. So also I hope that you can hear me and you can see my presentation. And we will start. If something will break, please tell me by voice because I cannot see our chat. Because I see only my presentation. So, I guess you know about the agenda for sustainable development, which was declared by the United Nations. There are 17 sustainable development goals in this agenda, and today we will highlight some of these goals in accordance with the topic of our lecture. So these are goals number 7 and number 13. And I suggest to start with the goal number 13 related to climate. We can highlight some factors which affect the climate. Among them are greenhouse effect, aerosols in the atmosphere, volcanic activity, also solar activity and Earth orbit parameters. To the investigations of climate on our planet, the scientists of St. Petersburg Mining University and also my colleagues from Scientific Center Arctic do these investigations in the Antarctica. So on the February they ended the 68th Russian Antarctic expedition, and materials which they received on the Antarctica, they help us to get information about changes in the climate of our planet thousands and thousands years ago. So we can look at this diagram, and this graph shows solar activity, and we can see that don't know any correlation between the solar activity. These average values are connected with the orange curve with the average temperature on our planet. But we can notice such dependence between greenhouse gas emissions or carbon dioxide emissions and the temperature on the Earth. And now we move on the next slide. Of course, it's well known that carbon dioxide plays a big role in global warming. So the left picture shows that annual carbon dioxide emission have increased many times in recent decades, and a little drop in 2020 we can explain by recession in the world economy due to the COVID-19. And let's look at the right picture. You see a map illustrated the carbon dioxide emissions by different countries. We should note a big amount of emissions by China, but we must also take into account that the large number of goods that China produces for the whole world. We should take into account this fact. This picture illustrates current situation in total annual emissions of some countries. As for Russia, emissions in our country are slowly rising. Of course, we may assume that emission reduction measures maybe are not sufficient, but and many developed countries with post-industrial economy, for example, United Kingdom, Germany, USA, and other countries, show steady decrease of carbon dioxide emissions. So, unfortunately, humanity is not able to disclaim emissions and stop climate warming. And our goal is to slow down the rate of warming. I guess you know about the Paris Agreement, which was accepted by almost all countries of the world. Of course, I want to say about Paris Agreement that it includes the goal to reduce emissions by 2 times in the middle of this century compared to emissions in 1990, and to reduce them to zero by the end of the 21st century. And as expected, of course it's not exactly, but these measures will allow preventing an increase in the average temperature on the Earth by more than 1.5 to 2 degrees of Celsius. And what about emissions by countries? The leading sector in the world emissions is electricity and heat. On the second place of this grade, the transport is situated, and a few less emissions are related to manufacturing and construction, agriculture, and so on. And let's look to the right picture. In Russia, the second place after the energy supply sector relates to fugitive emissions. Fugitive emissions occur during technological operations for the extraction, transportation, and processing of oil and gas. And also note that this slide is not about carbon dioxide, but about all greenhouse gases. For example, methane is 10 times more active as a greenhouse gas than carbon dioxide. And we can express the amount of greenhouse gases in terms of the equivalent of carbon dioxide. And let's go to the main consequences of global warming. Global warming leads to many negative situations. Firstly, global warming leads to reducing of fresh water supplies. You can compare two shots and photos of Greenland, and you will realize the scale of this problem. Secondly, it's a sea level rise. The figure at the top right corner of this slide shows that the sea level rises at approximately 3.3 millimeters per year, and a lot of cities are located below sea level, and they may be flooded in the future. As I know, most part of the listeners of our lecture today are from the countries south, which are situated south of Russia, and maybe they didn't know about that the fact that many problems associated with the melting of permafrost. On this slide, you can see different deformations and destructions of infrastructure in the north regions of Russia and other north countries. Also, we remember about changes in flora and fauna and natural disasters which are caused by global warming. So, what can we do to reduce carbon dioxide emissions? A good idea is to regulate emissions by a special program. Such program was developed in Europe. It's called emissions trading system, and also in United States of America. So there are different prices for carbon dioxide in different countries, and in some cases we can see different prices for different regions of one country, as in USA, for example. In Russia, carbon dioxide regulation is at the beginning of its development. In Russia, federal law number 296 on limiting greenhouse gas emissions was adopted only in July of 2021. So the energy sector produces the largest amount of emissions, and therefore another way to reduce emissions is to transform the energy sector. Renewable energy sources are an excellent tools for producing green and affordable energy. So the most common types of renewable energy sources are hydropower, solar and wind power plants. Of course, also we can include in this list biomass and geothermal energy, but the variety of energy sources is not limited to these types that you see on this slide. We can meet also examples of using of tidal energy, and even in Russia there is one station of tidal energy. But we will consider today only these types of renewable energy sources. As for Russia, the capacity of renewable energy sources is very small. About 0.5% of energy in our country is produced by renewable energy, and the installed capacity of renewable energy from the total installed capacity is little more than 1%. You see that in general the Russian energy sector can be considered quite low carbon. We see it at the top right figure. A lot of energy in Russia is produced by nuclear and hydroelectric power plants. Also, a significant part of thermal power plants use gas as fuel. Of course, it's better from an environmental point of view than using of coal or oil, for example. At the central figure, you can see dynamics of changes in the installed capacity of different power plants in Russia. And also such information which allow us to compare the installed capacity and share in total energy production in Russia and Germany, which is one of the leader in Europe in renewable energy projects. It should be noted that renewable energy sources in Russia is not only an expensive tool for reducing the carbon footprint, but there are a lot of remote regions with very expensive diesel electricity generation in Russia, and sometimes the cost of energy is more than 100 rubles per 1 kilowatt hour. So we can approximately convert this sum to $2-3 of USA per 1 kilowatt hour. Delivery of fuel is carried out by all types of transport. Sometimes the fuel delivery route takes thousands of kilometers, and integration of renewable energy sources into autonomous standalone power systems, of course, makes possible to reduce the cost of electrical and thermal energy. Let's talk about solar energy. The solar radiation potential is quite high even in the Arctic. You can see it in the picture on the top left corner of the slide. You can calculate the output of solar power plants. To do this, you can use a meteorological database with information about direct and diffuse solar radiation and also ambient temperature. And then, using a simple formula, you can calculate the output of solar panels. Also, some online resources make it possible to simulate production anywhere in the world. Now let's list the types of solar power stations. In the most common case, a solar power plant is a power plant with photovoltaic modules for direct conversion of sunlight into electricity. At the left corner of this slide, you can see top left corner Burzyanskaya photovoltaic system. Its feature is that it's equipped with a large energy lithium-ion storage. Another type of solar power plants is solar power plant with concentrators. These concentrators can differ one from other. On this slide, you can see parabolic concentrators, and they focus the sun's rays on a tube with molten salt. So this tube is very hot. Its temperature exceeds 500 degrees, and it cools down for several hours. And thus, power generation can continue for some time after sunset. A similar principle of operation is the basis of tower solar power plants. On the left picture, you can see the Crimean Tower power plant. It was liquidated after the destruction of the Soviet Union, and such tower solar power plants are popular enough in United States and Spain, Europe. Also, solar power plants can include parabolic dishes concentrators. For example, White Cliffs solar power station was constructed in Australian National University. Station consisted of 5-meter parabolic dishes, and each covered by more than 2,000 mirrors. So these dishes focused the sun's rays on a collector where water was boiled. The main manufacturer of photovoltaic modules in Russia is Havel. It produces various types of modules, and some of them have an efficiency up to 22%. This value is related to heterostructural panels. So on this slide you can see main advantages and disadvantages of photovoltaic generation. Firstly, of course, it's availability and renewability of the source. Low carbon footprint, but we should remark that it's right only for operation period and maybe utilization period of life cycle of photovoltaic panels. To the carbon footprint of solar modules, we will move through the next slides. Also, no moving parts. From the one hand, it's an advantage. For example, if we want to construct a solar power plant which will be exploited, it will work in the harsh climate, very cold regions, and of course the ability of constructions of such solar power station without moving parts, it is a big advantage. But from the other hand, of course, if we want to get a good value of capacity factor and to increase efficiency of energy generation, of course, we should add to our solar power system the tracking system, and in this case, of course, we will have moving parts. So increase in efficiency when operating at low temperatures. All manufacturers of solar photovoltaic modules get information about their technical parameters, which were measured at the nominal conditions, normal conditions of ambient temperature. This is 25 degrees of Celsius, and also the rated power which we will have from our photovoltaic panel. It's power during the solar irradiation of 100 kilowatts per 1 meter. So during the operation of photovoltaic panel, our panel will heat. The temperature of photovoltaic cell may increase up to 80 or 90 degrees of Celsius. So the efficiency will decrease below than the nominal parameter, for example, 20 or 22%. And in final, variability of location on the ground. So the solar potential on the surface of our planet changes when we change a location of our object of our solar power plant changes very slowly. So in most cases, in big cases, not big, often cases, situations, we can move our solar power plant, our theoretical solar power plant, when we also think about what location can we choose. And we will good efficiency and without harm to and decrease of our efficiency can do this operation. And now we move to disadvantages of solar power plants. Of course, it's impermanence of power generation, low conversion efficiency of solar energy. We said and told about it, and also you can see at the figure on your slides, which illustrates the best efficiency results for laboratory photovoltaic panels, and we note that this is best efficiency results. This diagram of National of Renewable Energy in United States of America is updates every year, and we see that nowadays, if to be more exactly, in 2021, the efficiency of best technologies is about 47%. But our industry for the mass market produce photovoltaic models with efficiency about 21-22%, and we should consider this fact when we calculate the theoretical power generation, when we use such maps of solar radiation. So the next disadvantage is low capacity factor. The good value of capacity factor for solar power plants is from 10 to 15%. I hope you know that capacity factor means. For example, if anyone don't know this fact, solar power plant with rated power 100 kilowatts, if it have a capacity factor 100%, it means that we have power of 100 kilowatts always in every moment of operation of this solar power plant. About capacity factor, we say on the range of time for the period of time. So this value for averaged on the year is about maybe 10 or 15%, It depends on this location and solar potential of this place on the map. Of course, large areas, and you know about this fact. Also, we can meet toxic materials in different photovoltaic panels, different technologies. For example, lead, cadmium, gallium, arsenic. Of course, not all types of photovoltaic modules contain these toxic materials. Also, high construction costs, the need to clean the solar panels from dust and snow, and you can look at in the corner, top corner of this slide. The figure illustrates frameless photovoltaic panels, and also on this figure you can see the traditional photovoltaic panels with the frames, and they are under the snow. Also, reduced efficiency due to heating, and we talked about this fact, and degradation of solar panels over time. Usually, manufacturers provide degradation of solar of photovoltaic panels not more than 15 to 20% during the life cycle of photovoltaic system. On this slide you can see the structure of costs for installing a solar power plant with a capacity of 1 megawatt in the Khabarovsk territory. This is a real case that can help you understand the cost of not only solar power panels but related operations. Of course, maybe it will be better to convert these values to not to rubles but to dollars, for example. But you can estimate the shares in these costs. And now let's look at some examples of the use of renewable energy, also in conditions of oil and gas industry. So many global companies have started their projects to reduce their carbon footprint and announced their goals, their own goals. Among them are Russian oil and gas companies. This slide shows solar power plants at the Omsk and Volgograd refineries. Of course, the economics of this project is a big question, but of course, renewable energy sources are sometimes used as a tool to enhance the reputation of companies. But as I said earlier, very often renewable energy units play an important role in energy supply. This slide shows a hybrid wind-solar power plant that supplies pressure pipeline control unit. Also, you can see other examples. For example, the system, autonomous system, which works using natural gas, but with the Stirling engine. And also you can see a system with solar panels and methanol fuel cell and also electrochemical battery. Such units and installations are very often used for energy supplies of oil and gas transport objects in Russia. Also look at Batagay solar power plant in Yakutia. Its installed power is 1 megawatt, and it is the largest photovoltaic system behind the Arctic Circle in the world. Now, also you can see small examples. Maybe it is the northern photovoltaic system in Russia, in the National Park Russian Arctic. The largest photovoltaic system in Russia is the Arshan photovoltaic system in Kalmykia, which is situated north of Caucasia. And the last example of photovoltaic panels, photovoltaic systems, this Burybaevskaya photovoltaic station is situated in Republic of Bashkortostan, and it includes monocrystalline photovoltaic modules. As I said, we should remember that even renewable energy has its own carbon footprint. For example, this slide illustrates the investigation of carbon footprint of photovoltaic cells. From 112 articles were chosen according to some criteria, 41 articles, and from these articles were chosen only 23 articles which are related to photovoltaic energy. And the results of these investigations are shown on the diagram on the right part of this slide. You can see that a lot of greenhouse gas emissions are connected with the stages of mining resources and manufacturing of materials, and then such stages as construction and utilization follow. And we move to wind energy potential, to wind energy. It's believed that the wind speeds of more than 4 meters per second are good conditions for the use of wind energy. On the left part of your screen, you can see a map with information about the average annual wind speed distribution in Russia. And we see that coast areas have a high potential for wind energy. This situation is observed not only for the conditions of Russia. Of course, you know about onshore and offshore wind turbines, and offshore wind turbines are very widely used in Europe, for example, in Germany and Holland and other countries. So the most common type of wind turbines are wind turbines with a horizontal axis of rotation. The main elements of a wind turbine are a tower, blades, and a gondola with equipment. And the picture also on the bottom left corner of the screen, you can see dimensions of wind turbines depending on their installed capacity. Other wind turbines have a vertical axis of rotation, and as a rule, these are low power wind turbines or experimental installations. As for advantages of wind energy, we can highlight renewability of the source, of course, low carbon footprint during operation, especially capacity factor is higher compared to solar power plants, and capacity factor of wind turbines is situated between, in most cases, it's situated between 30 and 40%. 40% is very good value for capacity factor of wind turbine, and also ability to create very powerful units without great amount of squares. And as for disadvantages, of course, impermanence of power generation, noise and vibration from work of wind turbines, presence of moving parts, and it leads to need for anti-icing measures, anti-icing treatment of blades by drone and helicopter. You can see on the right part of this slide. Also high construction costs, the need for transport and construction infrastructure, it can be a big problem in remote regions. Of course, we don't meet this problem when we want to construct our wind turbines in regions with a big total population, but for autonomous and standalone remote regions, it's very actual problem. And of course, variability of location on the ground is less compared to the solar power plants. So the wind potential depends from the form of Earth, on the surface of the Earth, and we should consider this fact. We cannot move our theoretical wind power plant to 1 kilometer to the left side or 1 kilometer to the right side without decrease or perhaps probably without decrease of efficiency of this operation. And economics of building an autonomous wind power station is showed on this slide. Also, this wind was installed in the Khabarovsk region in the coast zone, and it supplies power to the port base of the gold mining company. Its power is 100 kilowatts. An important Russian base on the Northern Sea Road is the port of Tiksi, and since 2018 its energy supply has been carried out with the help of wind power station, and this station consists of 3 wind generators, and also diesel. The complex energy complex of Tiksi includes diesel power plant. And on this slide you can see the largest wind power plant in Russia, Kochubeyskaya wind power system in Stavropol region. Also about carbon footprint of the wind turbines, we see that the main part of carbon dioxide emissions are connected with the stage of resource mining and manufacturing of materials, and of course we have carbon emissions during construction and operation. Also we want to estimate the generation of our future wind or solar power plant, and we can use data of reanalysis. This picture, one of these pictures, was made by us on one of the last slides, but on this slide I want to explain why should we use data reanalysis and what it means. So of course in the best case we can get information about solar potential or wind potential from the meteorological one of the meteorological station, but before the construction of renewable energy power plant, of course people collect information about renewable energy source during a long period of time. At least we speak about 1 year. But of course we cannot to receive data from our sensors, which we placed in place of interest for construction of renewable energy station. At first, we should estimate solar and wind potential without sending of this year and without installation of these sensors. So meteorological stations are not so are not situated very often on the territory, and the interesting fact is that the most interesting thing is what are the potential of wind or solar energy in remote areas. And you can see on this map that the total amount of meteorological stations in such regions is very small. Very rare meteorological stations we can meet, and because of this fact, we use the data of reanalysis, and this online resource is one of the resources which can provide to us such information of reanalysis. So the information which that we give from these online resources is calculations of the complex meteorological model, and we cannot know how this complex model works, but we can use the results of this operation. So we can receive information about meteorological data last years. We can receive information about potential generation of electricity for anywhere in different points of the map. And also, as you see on these figures, we can receive information about mainly monthly capacity factor and total mean capacity factor average on the year. And you can see that for Yakutia, in chosen point of the map, we have a mean capacity factor averaged on the year slightly more 10%. But in such months, for example, in April, May, and June, we have capacity factor more than 20%. And for Tixi, for wind generation, we have total capacity factor averaged on the year 28%, but in February, for example, total capacity factor of the wind power system is about 60%. The geothermal potential of the area is characterized by a heat flow maps, and heat flow is directly related to the temperature gradient. Minimum heat source temperature for the construction of geothermal power plants is 30 degrees Celsius. On the slide you can see heat flow distribution map of on the territory of Russia. And hydrothermal stations extract hot water or steam of natural origin, and they are subdivided into direct, combined, and binary cycle stations. So combined cycle geothermal station is in this case a steam water mixture with a temperature of more than 150% is supplied to the surface of the Earth. A separator is installed for separating steam from water. And then hot water returns to the well or releases additional steam under conditions of low pressure in the expander in some installations. On the right side of your screens you can see also simplified structure of petrothermal station. Petrothermal stations use the heat of rocks in the absence of geothermal waters or steam on the surface of our planet. They can be located anywhere, as at because any point on the planet, at any point the temperature of rocks rises with increasing depth. And geothermal power plant with hydraulic fracturing is named enhanced geothermal systems. Hydraulic fracturing may be natural if the rocks are porous or fractured, or artificial. And there are 20 enhanced geothermal systems nowadays in the world. Advantages of geothermal power plants are power generation stability. It's not typical for most of renewable energy sources. Compact layout, possibilities of simultaneous extraction of minerals, and the first geothermal power station also was created at the field of boric acid in Larderello in Italy at the beginning of 20th century. And low carbon footprint during operation. Disadvantages is very high construction costs. It's connected with high price of well drilling, working fluid hazard. In a matter of fact, steam water mixture may contain different toxic elements. Also, geothermal power plants cannot always be located in places where there are consumers of electricity. And finally, relatively low installed capacity of stations as a rule. It depends on the total amount of wells which are used. There are currently 4 geothermal stations in Russia. They are located in the Far East, and they are listed on this slide. Among them are geothermal power plants in Kamchatka and Sakhalin region. As for carbon footprint of geothermal energy, it's a rather difficult task to estimate the carbon footprint because we don't have a lot of examples of relatively with wind or photovoltaic power systems of using geothermal power plants. And of course, we don't have so many investigations in this area. But a middle value of carbon footprint of geothermal stations can be assumed at in a range from 25 to 45 grams of equivalent carbon dioxide per 1 kilowatt hour of electricity. Also on this slide you can see highly Hadley geothermal power plant in Iceland, and perhaps it is the first geothermal power plant with a negative carbon footprint, as was announced. And on this station, the special capture module of carbon dioxide with membrane with amine is used. This membrane then can be cleared by the waste heat from the geothermal power plant, and concentrated carbon dioxide we mix with water and move this mixture to the underground basaltic rocks, where this mixture turned into carbonate minerals. And some regions in the world have large reserves of bioenergy resources. Biomass is all types of plant and animal origin, waste products of organisms, and organic waste. Biogas plant converts organic waste into biogas. The left picture shows a biogas plant in Russia that uses animal waste to produce gas. On the right picture you can see a wood waste power plant in one of the forest regions of Russia, the Komi Republic. And now let's talk briefly about electrical energy storage devices. Of course, the most common storage device is an electrochemical battery, but there are a large number of other devices: mechanical, electrical, chemical, thermochemical, and thermal. On this slide I have placed one of the types of mechanical storage system. On the pictures you can see solid state gravity stations, gravity accumulator of the Energozapas company with a capacity of 10 kilowatt. Of course, it's very small power, but keep in mind that this is a demo project. Currently, the most common types of lithium-ion of electrochemicals batteries are lead-acid and lithium-ion batteries, but there are other types, for example, sodium-sulfur, lithium-sulfur, nickel-cadmium, nickel-metal hydride, and so on and so on. Also, at the end of the last year, one of the Russian leading companies, Rosatom, started to build a plant for the production of lithium-ion batteries with a capacity of 4 gigawatts per year. They bought this technology in Korea. Also, a few words should be said about hydrogen energy. So there are a lot of different concepts and scams and structures, and one of them is presented on this slide. This figure collects and accumulates different types of generation hydrogen, for example, by renewable energy sources, or the production of hydrogen from the natural gas by reforming of natural gas, and also includes different ways to use this hydrogen and accumulate this hydrogen. We can use it in fuel cells to produce electricity. Of course, we can use our hydrogen for oil and oil industry mainly. And of course, there are a lot of ways to use our hydrogen. So I guess you know about the color classification of produced hydrogen. So we subdivide hydrogen into blue hydrogen, which was produced from fossil fuels, natural gas, for example, or associated natural gas, oil by steam reforming, or partial oxidation, or autothermal reforming, but and it's the main condition with carbon dioxide capture and utilization. Without this system of carbon dioxide capture and sequestration, we may name this hydrogen as gray. It will be gray hydrogen. So Tokyo's hydrogen was produced from natural gas or associated petroleum gas by pyrolysis, by thermal pyrolysis, and green hydrogen produced by electrolysis of water using renewable energy sources. Currently, the most common way to produce hydrogen from methane is steam reforming. but it's not climate neutral. And as we told, this is gray hydrogen. And for production of green hydrogen, we need use our renewable energy systems. On this slide also you can see the first Russian electrolysis with a proton exchange membrane. Not alkaline, but proton exchange membrane. Hydrogen can be stored in high pressure tanks in the liquid or gaseous state, or in absorbed state in metal hydrate systems. On this slide you can see structure and principle of operation of fuel cell with proton exchange membrane. So we need to have hydrogen as a fuel for fuel cell operation, and we move this hydrogen to the anode zone, and also we move the oxygen, or for some types of fuel cells we need use clear oxygen or ambient air. We move it to the cathode zone. So when hydrogen meet the catalyst, it distracts, and the protons from hydrogen diffuse through the proton exchange membrane to the cathode, and two electrons go to our electricity chain. So, and in the catalyst of cathode, protons and protons from proton exchange membrane and electrons, and also two atoms of oxygen meet, and we give water as a product of the operation of fuel cell. Of course, to have fuel cell, it's not enough to use the system for power supply. For this goals, we use electrochemicals generators, and it's more complex system that includes not only fuel cell module or several fuel cell modules, but also such systems such as systems of preparation and supply of fuel and oxidizer, thermoregulation, voltage conversion, control management, and so on. Of course, historically, firstly, fuel cells were used in the space industry. On this slide, you can see several examples of electrochemicals generators, which were used at the Soviet spacecraft Buran, and the closed project of the lunar spacecraft also is shown on this slide. Developments of hydrogen cars was started in Soviet Union, not in Russia, as for our country. Of course, in parallel, in the world, investigations in this area were carried out. So in our country, before Olympiad of 1980, the first hydrogen car on hydrogen fuel was developed. But of course, using of such hydrogen cars was connected with great risks on the Olympiad, and that's why during competitions electric vehicles and buses were used. And in the middle of 1980 years, the studies of metal hydride storage systems were carried out. Then in the 21st century, we developed projects of cars on the base of fuel cells. The first project included a system with which could operate only on the clear oxygen, and then this system was developed, and oxygen balloons need not in this car. So this car could operate using ambient air. On this slide you can see a fuel cell stacks that was designed by the St. Petersburg branch of the Krylov Research Center. This is developed units from the Soviet space program, and then they were developed to the more modern units and implementations. The first hydrogen fuel cell tram in Russia was tested in St. Petersburg several years ago. Of course, this tram was not developed to be hydrogen, so the energy plant was situated at the all useful volume of this tram, but such very important parameters and tests were carried out. On this slide, the first Russian bus with hydrogen fuel cells, flying laboratory on the liquefied hydrogen. Of course, this aircraft didn't use the hydrogen fuel for in fuel cells. Of course, it had turbines which operate on the hydrogen fuel, but on the board of this flying laboratory fuel cells were situated, and they power supplied such several systems of on the board of this aircraft. And also you can see the world's first passenger aircraft. But also it used fuel cells only during the horizontal flying. And even hydrogen fuel cell mining truck was appeared several months ago. And the pilot project of hydrogen trains on Sakhalin was announced 2 years ago, and the planned launch of this project was 2024. But of course, we don't know will this project be realized or no. And power plant power units on the base of solid oxide fuel cell for oil and gas industry, you can see on this slide. Solid oxide fuel cell differs from a fuel cell with proton exchange membrane. As electrolyte, we use zirconium oxide, ceramic material, and through our membrane we not protons diffuse, but atoms of oxygen. So such elements can operate only during a high temperature, more than 500 degrees of Celsius. Also, you can see hydrogen fuel cell trucks, hydrogen fuel cell trains. We need use a battery because to control a fuel cell in direct connection is rather difficult because its operation depends on the big amount of different factors. So as a buffer, we use a battery. A placement of fuel cells and hydrogen storage systems. I had repeated this slide and this. And of course, the last thing that I will set on this lecture is that the problem of composition optimization of hybrid power plants with renewable energy sources is very topical and very important. The famous software systems for justifying the composition of hybrid power plants do not allow take into account original scenarios and system control algorithms, and also they have closed code, and the embedded methods do not take into account some factors that affect the result of solving the optimization problem. In this regard, other programs are also being developed at the mining university. We consider different factors influence on our optimization goals, and try to use these methodics to the real cases of operations of autonomous electrical complexes. So, thank you for attention, and we reach the end of our today lecture.